Welcome again, and there is a new picture, new problem, new situation to analyze. But I have taken a case of rolling without sleeping. That is pure rolling in this case. And you can see the picture, and you will be wondering a cube again, a cone again. Cones are quite popular these days. And IITs once asked a problem related to a cone. So everybody is looking to find few secrets about a cone. But this is not exactly the part of your syllabus. Because somehow it includes a case that is not the part of plus 2 syllabus. But let's look at the picture. There is a cone with a height h equals 4 centimeter and a base radius 3 centimeter. Rolls along a horizontal surface without slipping, with a fixed apex at point 2. Determine the angular velocity of rotation of the cone relative to the lab frame associated with the surface lab frame. If the cone makes one revolution around the OZ axis in time t equals 3 seconds, time period is given, and we need to find out the angular velocity of the cone associated with the lab frame, with the reference frame attached to the lab frame. Which omega is this? A little arrow here, and you will be wondering what this arrow is doing here. And I have something to say. Let's see this picture, the second one. Should I make this bigger? This picture. Look at this picture. You know what this point is? This point. This point. This name is A. What is this A? Well, A is the point of contact of the cone with the horizontal surface on which it is purely rolling. This is point A, yes. And this point A is at rest with respect to the ground, because this is the required condition of pure rolling. And it means an instantaneous axis of rotation about which the cone is in pure rotation is passing. You can see this axis is the instantaneous axis of rotation at a point of which the instantaneous center of rotation is sitting, lying, and about that point the cone is in pure rotation, only rotating. Otherwise, from the lab, we can see a rolling body as translating and rotating, or we can visualize a rolling body in pure rotation. Translation and rotation is easy to observe, but pure rotation, you need to have an instantaneous center of rotation and a line passing through it Remember, infinite number of lines can pass through a point. So you have to correctly choose an instantaneous axis of rotation. And I have only this much information, that this instantaneous axis of rotation passes through the instantaneous center of rotation. So at your risk, you can get this. And this is the principal axis. So this is the angular velocity you are looking for in this problem. This is the angular velocity you need to find. This is your job, and you can do this very easily. Because this omega is nothing but this omega is sum of rotations, sum of all the omegas. There are other two, omega 1 and omega 2. Omega 1 is the rotational velocity, angular velocity about an axis OC, about which the cone is just spinning, passing through its center, OC axis. Omega 1 is its spin angular velocity, and by omega 2 it is orbiting around the z axis. So this is omega 2 is its orbital angular velocity, and the principal axis, the velocity about principal axis, you can always finding by adding up the angular velocities, by adding up the spin angular velocity and the orbital angular velocity. So I got it. Though velocity of its center, velocity of the center of this cone can be written in terms of its total angular velocity, orbital angular velocity, or spin angular velocity. Suppose that velocity of center can be written in terms of orbital angular velocity like omega 2 multiplied by r. R is not mentioned here. R is not here. You have to wait to find R. And this can also be written in terms of total angular velocity omega multiplied by radius. That radius is also not mentioned here. This is not a small r. This r is certainly not equal to h, the height of the cone, and this thing I would like to write it f. This f is not equal to a small r. These are two different quantities you will be needing, and but omega c center of omega c, not vc, the center of the velocity of the center of the cone can be written in terms of omega t, omega 1 and omega. And omega 2 was given in the problem. Omega 2 was given that the cone makes one revolution around the OZ axis in time t equals 3 seconds. So omega 2 was given in this problem. And omega 2 was nothing but this was 2 pi by t time period that is given, omega 2. But we need to find omega. And if we equate these two terms, omega r equals omega multiplied by f, r we don't know, f we don't know, omega 2 we know. If we find r and f, we can find omega. So let's find omega. And to find omega, we need to find f and r. What is f? What is r? You don't know. So let us see this diagram from a different angle. This diagram from a different angle. I would like to see is one axis, and this is some line, and I am watching this cone from a side. So cone will look like this to me. Half of the cone I am drawing, because this is the center, this is the z-axis, and this is the surface. This is the instantaneous center of rotation, because here is the instant, this axis is instantaneous axis of rotation, because this is the instantaneous center of rotation. This point, this is center, and this is height of the cone, and this is the radius of the cone. And I'm going to tell you, this is the R I have mentioned earlier, and this is the F, the height, the center of the cone, and radius. And cone surface is not really vertical. The base of the cone is not vertical. By cone, put on the horizontal surface. Look at this closely, and you will find I'm true. So I needed to find this F, because this cone is rolling like this, so I need this F. And how can we find it? There is a similarity. I think this triangle is similar to this triangle. These two are perpendicular to each other. These two are perpendicular to each other. So if I consider this the main triangle, this is the triangle made of perpendiculars. So I can write here, first thing I can write here R, this length is F, and this is H. So I can write here R square plus F square equals H square. That means F equals H square minus R square under root. But F is not known, so I'm going to use the similarity of these two triangles, and I can write R upon F is equal to R multiply R upon F is R upon F is H upon R, capital R. So I can write here R upon F is equal to H upon under root H upon R upon F. So why I'm going to do this. I can simply write R upon F is equal to, I should have found R rather than H here. R should be equal to H square minus F square. That was correct, but I needed R. I wasn't sure. So H divided by under root H square minus F square. And that's, you can see, I made a deal. You can find both values. You can find the value of F here, and after then you can find the value of capital R if you need to. We needed both F and R, so I can find the value of f here, and if I will get something like r in terms of r and h, because they are given in problem. R h under root r square plus h square, and you can get r capital R as well, and that will be h square upon under root r square plus h square, and once you get the values of r and f, you already have the value of omega 2. You can get your value of omega. And thank you very much for watching.